Cool. So I think we'll make a start. So welcome everyone. Welcome to the SpecFlow guided onboarding session. So the session's purpose is to get you familiar with SpecFlow, what it does, how you can use it. Hopefully some people are following along. If not, no worries. It's completely up to you. So to introduce myself, if you don't know who I am, my name is Jordan and I'm the user journey engineer, support engineer at SpecFlow. So my primary role is to, as it may seem obvious, is to support the users to use our tools. So just a couple of things. It's a hands-on session. So like I say, if you plan to follow along, then I'll try to slow down a bit because I can get carried away sometimes and go through real fast. And if you have any questions, do let me know. Pop them in the Q&A. They may get lost in the chat today because I'm by myself, so I've got nobody moderating. So make sure you put them in the Q&A, and we'll have time to answer those at the end and upvote any that you like the look of. So today, like I say, because I'm on my own, probably point number 3 we won't be able to do, so we'll just we'll do the Q&A at the end, as I've not got anyone to moderate for me. So just so I get an idea of who may have used SpecFlow before, you should see a poll on the screen. So if you could answer those for me, that would be good. Okay, so it looks like quite a few people actually haven't used SpecFlow at all, so, and a few of you that have. So I'll try and fit in as much detail as I can. But with that, let's get started. So I'll just close this presentation. Cool. So I guess the first thing to just talk about is, what is SpecFlow? What does it do? So any of you that might have heard of Cucumber, which is basically the Java and many other languages actually implementation of or tool for BDD. SpecFlow is the official .NET BDD version of Cucumber, if you like. So what it aims to do is provide a means and ways of you writing business readable specifications for your applications in a nice, clear format. 70+ languages are supported at the moment. So, it doesn't matter. It doesn't have to just be English. It can be, Portuguese, German, or whatever your, whatever makes sense for you, or whatever your native tongue is. So we provide an extension for Visual Studio 2017, I think is still active, 2019, 2022, and also JetBrains Rider. So if you prefer using Rider, then we have the extension there too. So I'll start off by showing you how you can install the extension. So it'll be the same across all of the IDEs. So we'll open the IDE, and we'll just continue without code for a second. And if you see the extensions section at the top here, we can go to manage extensions, and we'll just search for SpecFlow, of course, and we'll hit download. And with Visual Studio, we'll need to actually close the application down. You'll see this VSIX installer, and we'll just click modify. We'll just wait a couple of seconds here for that to install. Hopefully it won't take too long. And then we should be able to open the IDE and start looking at some of the SpecFlow features. Again, if people are following along and I'm going too quickly, then do shout. Cool, good. So you should see that the extension is installed, so we can close this down. So let's reopen the IDE and we can get started. So the first thing we're going to do is create a new project. Create a new project, not open one. And what you'll see once you have the extension installed is you should see this SpecFlow project template. And basically what that is, if we click next, we'll get to name the project as normal. So we'll call this SpecFlow calculator specs. And we'll create this, and we should get these options here. So this is part of the template. So what this means is, depending on what you choose, you get some boilerplate code essentially to set up the project, just like you do with any other kind of project template, like a class library or web app or whatever the case might be. So let's select, I think I said .NET Core in the first slide, so we'll choose .NET Core. .NET 6. Not having a good day today, clearly. And then you get these test framework options. So again, this will add some boilerplate code in for the test framework. In this case, we'll choose NUnit, but it should be the same. We're not going to do any configuration in terms of the framework today, so any of them should suffice in terms of the demo. And there's this additional checkbox here to do with our assertions library. So NUnit has an assertions library, but we actually like Fluent assertions because it's nice and readable. And that's kind of the whole premise of SpecFlow, really, is to be readable. So that's why we include that. And if you give it a tick, then it will install the NuGet package for that automatically. I'm not sure what this is doing. This appeared before, so let's hope something happens. And if we go to the Solution Explorer window, let me just get rid of this properties window. Hopefully you can see this okay. So in the Solution Explorer window, we'll see the boilerplate code that I mentioned before. So you get some empty folders and you get some folders with some stuff in. So you can see here, so the way SpecFlow works is there's a particular file format called a .feature file. So let's take a quick look around. And this is the default template that you get. You can delete this and create your own. Skip over this update log here. So what you'll see right out of the box when you create a new template or create a new project, sorry, is this calculator feature. So a feature has a title, and calculator in this case will make sense. But you can call it whatever makes sense for you, whichever what's the word to say, requirement that you're describing the scenarios for. I guess it might be some login feature for your application, for example, and this is where you would specify your requirements effectively for that feature. So we start off with a scenario. In this case, we're adding two numbers, and then we have this given when then format, which is the Gherkin language, which comes from Cucumber, as I mentioned earlier, which is the Java and other languages side of things. So obviously we use the same syntax. So the way it works is we have this given when then format, and each of these lines here is effectively bound to a piece of code, which we'll see in just a second. And that's how it execute these tests effectively. So if we just do a quick build here, what we should see in our Test Explorer window is we should already see, let me just drop that there. You'll see this the specs here, and then you'll see this calculator feature, and then add two numbers, much like you would see in unit testing effectively. That's kind of what this is. It's an abstraction layer above the unit tests, so it works in the very same way. So we'll get into detail in this in a bit more in just a second. What we need first of all is something actually to test. So I'm actually going to add another project to this solution, which will just be a class library. And we're just going to call this SpecFlow. I could spell. And .NET 6 as well, and we'll create this. So you can ultimately use SpecFlow to automate anything. It doesn't have to be some code inside the same project. It could be, the UI of an application, whether that's a web app or a desktop application or an API. All of these things can be tested because SpecFlow is a flexible framework, and it's not really tied. It's not really tied to anything concrete, right? So each of these steps, as we'll see in here in a minute, can be attributed to any code at all. So it gives you the flexibility and freedom to kind of do whatever you like with it, really, which is super cool. So I'm just going to delete this class 1. And I'm going to add a new class. Call this calculator. This will be our subject under test, or whatever you want to call it. Just going to make this public. And we need to define some things that a calculator would do. So I'm just going to copy and paste some stuff I've got here over across, and then we'll talk through this. So it's going to be a simple calculator. So we've got 2 properties. We've got one first number and one second number, and then we've got this method here, or function, or however you want to call it, add, and ultimately this will do something, and we will test that something in just a moment. So if we go back to the feature, so you might have noticed that these were purple before, and what that means is that they're not linked to anything, and we'll come on to that in just a moment. But now they're black because the boilerplate code that we have here. I'm doing a horrible job of describing this, but so say for example, let's comment this out, and then if we rebuild, and so this particular method, given the first number is something, and we have this parameter here, this int parameter, it actually matches via the step in the feature. So it has this regular expression here, and that's how it's controlling the binding between your feature file and your code. So if we go back to the calculator feature, you'll notice that this is now purple, and this indicates that this actually has no implementation yet. So if I press F12 on the keyboard, which is navigate to the code, it says the step is undefined. Do you want to copy step definition skeleton snippet to the clipboard? And we could click yes, and then just copy and paste that skeleton from the clipboard straight into our step definition. But we'll talk a bit more about this in just a second. I'm going to uncomment this, and you might also notice that if we rebuild, these numbers are actually parameters picked up by this regular expression and are passed into our implementation effectively. So everything's bound, so therefore something should run. So if we just run this, we'll just see what happens. Excellent. Okay, so we see this asterisk here, and if we look at the output, we see the message 1 or more step definitions are not implemented yet, and it gives us the first one that it hit, where it basically threw the exception, and of course it is this pending step exception. And the reason I'm showing you this is because you can kind of in the output, you can see, you know, what's happened, what's gone on. So we'll see here, given the first number is 50, this is pending. Second number is 70, skipped because of previous errors, and the same follow. So let's do something about this. So we have a calculator, so we can go ahead and use it. So let me just clear out some of these comments because they're hurting my eyes. So first things first, we need a reference to our calculator, and actually I'm just going to do that. So if we add project reference, SpecFlow calculator, that's from the Solution Explorer window. If you're not familiar, right click on your test project, go to add project reference, and then you can add a reference to the project that you're looking to get access to effectively. So what we're going to do is take advantage of something that SpecFlow offer. This actually happens behind the scenes, which is nice. So it's a form of dependency injection. So if I just create this constructor here, without really doing any registration, like dependency registration, we can actually inject an instance of this object into our step definition file, which is perfect, obviously, because we need access to it. So if anyone doesn't know how to use IntelliSense to automatically create a field, if you highlight the field or the parameter and press Control and dot, you'll get this menu here, and you can just click create an assigned field calculator, and it automatically does the assignment for us, which is nice. So now we have access to our calculator. So if we whip back over to our calculator, we can now, assign a number to our first number, our second number, and then call this add method. So in fact, let's just let's implement this. Oh, IntelliSense is doing my work for me. So simple calculator operation, but something simple we can showcase and demonstrate. So if we go back to our step definition, we go to the first line. So if we come back here, we say, given the first number is 50, which is our parameter. So if we press F12 on this, it takes us right to the declaration here. So we'll say this dot calculator dot first number equals number, and that's it. That's that bit done. And we'll do the same thing again with the second number. Again, IntelliSense is doing my work for me. And then now we can do our acting. So for anyone familiar with unit testing, you have this concept of arrange, act, assert. The same is true using BDD. So our given is our arrange, our when step is the act, and the then step is where we typically do our assertions. So hopefully that provides a bit of context. So so performing our add, and now or does this return? Oh, it returns the int. So we need to create a local field for our return value. Result. So we'll say this dot result. Oh, so we now have a reference to the result inside of our step definition. And now we need to do our assertion to get our result. So what we'll say is this dot result. And this is where the fluent assertions library comes in. Should. So if anyone's not familiar, this should be is part of the fluent assertions library. It's super readable, as hopefully you would agree. You can see it on screen. It's linear. You know, you can see exactly what's going on. So our local result should be the result that we're passing in. So if we flick back to our feature, this is our expected result, obviously. And in fact, these should be, I think, the other way around. So the expected comes first, and then the actual is in here. I wonder if it tells us in the, oh no, it's the other way around. I was right the first time, but either way, you can see how this is kind of working. We're just directly comparing the integers together. So if we now run this, we should hopefully see, and actually I might just debug this so you can see exactly what happens. So we can put a breakpoint in our feature. And if we hit debug, we should break on this line, and then I should be able to just F11 through the code. And we do. So we should be taken into the constructor of the step definition. So you can see here, this is where the calculator is automatically being injected via SpecFlow behind the scenes, bit of magic. We do the assignment. So the first number we're getting from this here. So you can see in our feature, the parameter is 50. So we're getting exactly what we expected. And the same is true for, excuse me, these other, just click no there, these other methods. So we'll just continue to go through, and like I said before, you know, it's flexible. You can put anything in these methods, anything at all. So you can automate the world. That sounds a bit cliche, but it's true. You can do anything you like. You're not bound to do anything in particular at all. So I'll just, I mean, I think you get the point. So I'll just continue the execution, and we can see now that we have the result. Everything's looking good, and in the standard output, we can see the timings, the calls that were made, and that everything's fine, and that we get what we're looking for, which is the result, and the duration obviously extended because we were breaking through it. Cool. So now I will show you how we can extend. So, you know, maybe you and the team, you're talking through a particular story, and there's some requirements coming up. Maybe our calculator needs to do something else. not just add two numbers, because it's a, you know, pretty boring calculator. So what I'm going to do is just copy and paste this scenario, and we'll call it subtract two numbers. And we can actually reuse a lot of this stuff. In fact, everything other than this act line. So we'll just change this to when the two numbers are subtracted. And this is actually the beauty of, you know, the given when then format and reusability of code. We're adding a whole new scenario, but actually all we're doing is we're adding one new piece of functionality and the rest is just being reused. So let's change these numbers a bit. We'll say the second number is 50. So we expect it to be 50, of course. And as I mentioned before, anything that's not implemented will show as purple. So you can either right click and go to the definition, or the shortcut is F12, or you can actually say you've got a whole bunch of different steps that aren't defined. You can do them all in one hit. And it will actually, if there's no corresponding step definition file, it will also generate the new step definition class for you, which is cool as well. If you do that, it will actually overwrite the whole file at this point, because the file already exists. So we'll just click copy to clipboard, and we'll go to our step definition file, and I'm just going to paste this in here. So you can see it's generated the attribute, it's generated the regular expression, and the method name and signature. So all we need to do now is add some functionality. So we'll say this dot result, this dot calculator, and we don't have a subtract method yet, but we can again control and dot on this, and we'll generate the method subtract. And let's pop into the calculator, and we'll do the same again. Thank you, IntelliSense. And we'll save this, and that's kind of it. We should be able to just build this. We should see a new test appear. And providing that I haven't messed anything up, this should just execute perfectly. So we'll see if that's the case. Oh, whoops. First number is 100, second number is okay. Am I being dumb here? And it's expecting minus 50. Oh. Cool. Let's run this again. Hey, good, cool. So excuse my my idiocy, but so that's what we expect now. That's what we expect to see. And we could continue. So we could add, you know, divide, multiply, and it would just be a case of rinse and repeat. We'd add another when step, because that's when we're doing something. You know, we've already done the precondition and the assertion. We're just passing in these values dynamically into our methods, and then really it's only the when step where things are changing in this case. Obviously it can be more complicated, and obviously this is a very basic example, but that's just how easy it can be when you've got simple you know, simple features. So we'll just talk about some other things you can see here. So let's just get rid of this. What you can see is there's some what's seemingly text, just random text, but actually this is markdown syntax, and the reason for this we'll come on to in just a moment. But what we do have, you might have seen it, this living doc generator, and what this living doc generator does is it actually generates a living doc in HTML format, so you can open it, you can share it. You know, you can generate this stuff via your CI/CD pipelines, host it somewhere, whatever you want to do. It's just a HTML file. You can, you know, you can do with it what you want. You might notice here there's a reference to a PNG file, so you can add pictures. You can, you know, add links, whatever. You know, you can actually add links to, say, for example, if we had a particular test case in Jira or Azure, using these tags, I'll probably talk about what tags is in just a moment. You can actually link to, these work items, these tickets, if you like. So if you're viewing the living documentation and maybe you're a tester, or maybe you're a product owner, you can go directly to where this particular feature was implemented. Maybe it was done 2 years ago, maybe it's new, whatever. It's just a quick way of you linking to these tickets where the feature was implemented, and it's a nice record essentially that you can easily view. So let's do that. Let's look at the living doc. So there's 2 versions of it, and just to reiterate everything I'm speaking about, if we just open this and you go to SpecFlow. 2 seconds. Here, you go to specflow.org under docs, and if you go to SpecFlow, all of the tools, the open source, the closed source ones that we provide, all of the documentations here, you can see how to do all of the things that I've talked about and more. And there is a step-by-step guide. So if you haven't followed along with me just now, you can check out this guide and do it in your own time. And it's ultimately the same thing. If you want to get familiar with SpecFlow, feel free to browse this at your leisure. So back to the case in point, it's the living documentation. So there's 2 versions. There's a plugin for Azure, which will automatically generate this doc for you in your CI/CD pipeline. There's actually a command line version of the tool as well, which you could also execute via your CI/CD pipeline, but I guess more useful for if you're not using Azure or if you're just generating these things locally. And the way to install it is via the command line. So let me just paste this in the chat so you can all see it in case you're following along. So .NET tool install global and specflow.plus.livingdoc.cli. So if we punch that, we should hopefully see some green text. Cool. So it's automatically grabbed the latest version and installed the local tool globally to the machine, so we can begin to use it. So the first thing we need to do is the command is living doc test assembly. So we need to provide the DLL file that's generated by our test project. So we'll just navigate to the file explorer. And if we go to source, repos, specs bin, so basically the output directory, and we'll look for our am I being blind? Calculator.specs.dll. This is the one we need. And if we shift and right click, we'll get the option to copy as path. So if we pop this in here, and that should be it. So let me just punch this. Oh, good. There's some errors, but it looks like it's still generated it successfully. So I'm not too concerned about that. So if we go back up a couple of notches here, I think it will be in here it is. Cool. So it's actually in the user folder. So you'll see this living.doc.html. You can specify a path to generate it somewhere else, and you can of course change the name, but let's open it and have a quick look here. We'll open it with Edge, and you get this nice HTML report. So if we have a look here, this comes straight from our features folder. So you can see calculate features here. And if we click on this and expand it, you can see the nice image here that you can add. And here are our test methods, add 2 numbers, subtract 2 numbers. And you can see these links. Feel free to obviously do this yourself, navigate to these links. So if we click here, I'm not actually sure what I just did. Link to a feature. Okay, right, it takes us to the feature. And then this presumably will take us to specflow.org, and it does. Cool. So just showcasing the point in hand. You can have links, you can have pictures. It looks nice. You can also filter. So if you've got an enormous project, you can filter by tags, by the titles, by the steps. by the descriptions, as you can see. I'm just reading this to you effectively at this point. But you can filter. So say, for example, you have, I don't know, a bunch of UI tests amongst other types of tests in your project. Maybe you've tagged them with this tag here. So let me just show you the tag, this tag. Maybe you've tagged them with UI test. So you can filter by tags, and you'll see there's only one here, which is my tag. You can see that it will return all of the scenarios and the scenarios that have this particular tag on. So it makes, this is for non-technical people. So, we live in a world where testers, developers, they're kind of doing their own thing. And maybe the product owners don't usually see this kind of thing, but they're probably interested. They're interested to know what's going on and, the kind of test coverage we have, maybe, or not even that, just the requirements documents. You're documenting the requirements of the application, right? So this is useful for everyone, business analysts, product owners, scrum masters, whatever the case might be. It just makes it clear and visible instead of saying, showing this to your product owner, because really, it's almost meaningless. It's not, but it's not clear. You can't share it easily, etc., etc. So the keen-eyed among you may have noticed this analytics tab. So what we'll now do is we will generate this doc with test results, because as part of the template, and I probably should have mentioned it earlier. So if we go to dependencies, sorry, wrong project, dependencies, packages, we'll see that we have this SpecFlow plus Living Doc plugin. And what this is actually doing when we're building and executing the tests, we're generating a test results file in a JSON format. And we can add this and pass this into our Living Doc. And then we get access to all of these cool things. So let's just go back into the project. And again, it appears in the project root. So if we go here, we should be able to scroll down and see test execution.json. So we'll shift click and we'll copy as path. And the parameter for this is -t. And we should be able to just generate the same file again and refresh. But this time you can see that we've decorated the page with the results. And you can see subtract 2 numbers here. And likewise, if it fails or there's some other reason that the test hasn't executed, then you'll see this too. You can extend this by adding, messages in between the steps. So if you want to log something and have it easily accessible, the exception perhaps, or maybe some pictures, take a screenshot, all of this stuff can be extended here. You can go to the docs and read up on that. Not sure why the other one, unless did we execute without, let me just rerun both of these and then we'll generate it again. I just want to make sure things are working properly. Let's regenerate. We're good. And hopefully we should see both the result. We do. Okay, cool. It's having a bit of a moment there. Cool. So let's have a look at the analytics tab. So now we can see the number of features, the number of scenarios, the number of steps themselves, and also unused step definitions, which is actually really, really useful. So in a previous role, I worked on a massive automation project. And, there was probably 50 people working on this test automation project. Everyone's refactoring, everyone's making changes. Sometimes things get left behind, right? So what this unused step definitions will do, so let's just, let's copy and paste this then. And we'll call it something different because the compiler will complain or something. We'll get rid of this parameter. And we'll call this name something, and we'll rebuild this. We'll quickly just generate this again. And now what we should see is actually, great, demo gods are on my side, clearly. It should, let me just, great. Hold on. Okay, we've rebuilt. Let's see if this is going to play ball. and it's not. Oh, it's my fault. 2 seconds. Okay, and I'm crossing my fingers. Cool, it's not appearing. I'm not sure why it's not appearing. But what this would usually show is, and there's something I've done wrong, no doubt, but what it would show is any references to any old unused step definitions. So you can go through them and just sanitize everything, clean everything up. So that is pretty much it. I've noticed there's nothing in the Q&A unless I've missed it. There's still, 23 minutes to go. So please do ask any questions now if you have them. I'll just give you a couple of minutes. There's some other things I could show you, a little bit more complex. I'm not seeing any questions, so I'll continue to talk. As I'm talking, please feel free to ask any questions that you may have. If there's no questions, I assume I've done a grand job of explaining things, which I'm sure isn't the case. So one thing I will show you is sometimes, before your test execution starts, or after it ends, or in between, in fact, there's some things you might like to do. Maybe you want to log something, maybe you want to do some environment setup, that kind of thing. There's actually, we call them hooks. They're just, they're methods that are decorated with an attribute that at runtime understands that these things need to come before the tests start, basically. So if I just right click on this folder, go to add a new item, and you will see, if I search for hooks, you'll see there's this SpecFlow hooks and there's event bindings. I'll just call it hooks for simplicity. Usually people might use this for container initialization and registering dependencies, that kind of thing, before the scenario begins. But as you can see from the boilerplate code here, you can filter these things by tag. So, say you want to do something, but only before your UI tests, you can say, you can decorate this method and say, I only want this to execute if it has a tag. So if we want to, launch a web browser and go to a page, whatever the case might be, you can scope it specifically so it only executes for that particular set of tests, or test, if you like. You can see here, you can order them. So if you've got a couple of these hooks, then you can make sure that something happens before something else. And there's some other ones as well. So there's this before scenario, after scenario. There's one which is before test run, which will happen even before, obviously, the scenarios. After test run, there's one for after step. So in fact, let me just change. So you can see here, we've got after step, after test run, after scenario block, after scenario, after feature, etc., because there may just be things that you want to do in between, starting a new feature, log it, maybe take some screenshots, report some result, maybe you're integrating with Browser Stack and you want to report the test result to them, whatever the case might be. These are things you can hook into in between the execution that you can guarantee will happen. So that's what the hooks are all about. I still see no questions, and that's kind of it. So that's all I had to show today. I will say, if you want to explore more about the things I've talked about, please feel free to go and view the documentation. Everything is here, so you should have a pretty stress-free, experience following through the guide and the documentation to try these things out. Let me just paste that in the chat. Oh, another thing to mention is we have a school. So if we look on, if we go back a step here, learn SpecFlow School. So what this is, at the moment, there's only one course. Obviously, we're due to expand these things. It's 4 hours long. It's broken down into, I believe, in fact, let's be sure. There's different lessons. Can I see how long they are? No. Okay. So if anyone hasn't heard of Gaspar, he's you could call him the godfather of SpecFlow or BDD with SpecFlow. So he's one of the founding members of SpecFlow, so he knows SpecFlow inside and out. And although he's not still part of the core SpecFlow team, we do contribute with him frequently on expanding SpecFlow. But basically, he runs this course. So it is very good. It is 4 hours in total. You obviously can do it. It's on demand. You can do it whenever you like. It just requires you to sign in. So if you click enroll, for example, you can create an account. If you already have one, you can log in. But a lot of people have found this very useful. And at the end of this, you will get a certificate that you can share on your LinkedIn. And obviously it's the content is there for you to come back to if you want to brush up on something. But he goes into a lot of depth about, you know, the process of using BDD effectively from kind of start to finish. So he talks about the concepts of how you write the scenarios, how you write the features, you know, how to do the automation, and lots more. So I would encourage you to go and check that out if you haven't already. But that's kind of it. So let's go back to the slideshow, and I'll just wrap things up here. So there's still no questions in the Q&A, so let's move on. So with SpecFlow being open source, we have this community heroes program. So whether that be, you submit a contribution directly to SpecFlow in the repository, or maybe you create some educational content on YouTube, maybe you make a blog post. Let us know in the forum. So there's on specflow.org, there's a forum section where you can submit your hero contribution, and three heroes per category, words are hard today, per month will receive a $25 Amazon voucher. So do let us know, don't let your contributions go unheard. And that's it. So do, visit specflow.org, follow us on Twitter, LinkedIn, and all of these recordings are always uploaded to YouTube after the webinar. So do go and check out the other webinar recordings we have. We've got lots about all of the tooling that we provide. So feel free to go and check them out, and thank you for attending today.